What if our universe got hit by something? Not a meteor, not a black hole, something from outside. What if the universe has a bruise, and it's staring right back at us just past the constellation Eridanus? This is not a theory. This is on the map. The Bruise in 2003, NASA's WMAP telescope took a picture of the oldest light in existence, the afterglow of the Big Bang itself, frozen in the sky at a temperature of 2.725 Kelvin. That's minus 454 degrees Fahrenheit. Colder than anything that has ever existed on Earth. And this light is almost perfectly uniform. Hot patches, cold patches, all of them tiny, all of them normal, except one. In the lower right section of the sky, there is a region that is 70 microkelvin colder than the average. 70 millionths of a degree. Sounds tiny. But in the language of the Big Bang, that is a scream. Typical cold spots in the CMB are about 1 degree wide. This one spans 5 degrees across the sky. Think of it this way. Hold your fist at arm's length. That's roughly 10 degrees. The cold spot is half your fist. In cosmic terms, at the distance of the Big Bang's afterglow, that half fist represents a region roughly 1 billion light-years across. When scientists ran simulations, millions of virtual universes built from the same rules as ours, fewer than 2 out of 100 produced a cold spot like this. It's not impossible, but it isn't comfortable either. It's the kind of thing you stare at for a long time, and then you stare a little longer. The what-if simulation in the same direction as the cold spot, not at the edge of the universe but much closer, sits something that cosmologists call the Eridanus Supervoid. Not a black hole, not a collapsed star, a hole in the structure of the universe itself. 1.8 billion light-years wide. Let's sit with that for a second. The distance from one end of this void to the other is 18,000 Milky Way galaxies, laid side by side. 18,000 of our entire home galaxy. Gone. It is not empty. Not completely. There are galaxies in there. Scattered. Thin. Roughly 1/4 to 1/3 fewer galaxies than a typical region of space this size. Think of a city after everyone leaves. A few people still wander the streets. But the restaurants are dark. The lights are off. And no one is coming back. Now imagine that city is 1.8 billion light-years wide. If you somehow stood here, in the dead center of the Eridanus Supervoid, the night sky would not go completely dark. Your own galaxy would still glow around you. Stars above. Stars below. But look beyond your galaxy's edge and you would see almost nothing. No Virgo supercluster glowing in one direction. No Coma cluster in another. Just distance. And silence. And the occasional ghost of a galaxy too far away to matter. Here is what makes this structurally unnerving. Our entire Laniakea supercluster, the gravitational basin that contains the Milky Way, the Virgo cluster, and 100,000 other galaxies, spans roughly 500 million light-years. The Eridanus Supervoid is 3.5 Laniakeas wide. You could vanish our entire home supercluster into this void with room left over, and it would barely register. Now, here is the thing that cosmologists keep coming back to. When light from the Big Bang, CMB light, passes through this void, it loses energy. In an empty region, the universe's expansion stretches space faster than normal. The gravitational hills that CMB photons have to climb become taller as they climb. They arrive on the other side slightly colder than when they started. This is called the integrated Sachs-Wolf effect. And the Eridanus Supervoid produces it. The problem is, physicists calculate it can only account for about 10 to 20% of the cold spot's full temperature drop. 80% of the cold spot's coldness remains unexplained. So what made it? The Bruise hypothesis in 2007, before the Eridanus void was even confirmed, a physicist named Laura Mersini-Houghton made a specific prediction. She said, if we live in a multiverse, a cosmos of countless bubble universes, each one born from a quantum fluctuation in the fabric of reality, then our universe should carry scars from before it was born. not just any scars. A specific kind. She predicted that in the direction of a large CMB cold anomaly, there should be a colossal void in the matter distribution. She said this before anyone had found the Eridanus Supervoid. Then the Eridanus Supervoid was confirmed. And it was exactly where she said it would be. The theory goes like this. Before our universe inflated into existence, it was entangled with neighboring universes in the multiverse. These interactions, these quantum connections, left imprints on our universe's starting conditions, like a fingerprint pressed into wet clay before it hardens. In a more extreme version of this idea, the bubble collision hypothesis, our universe physically grazed another bubble universe in the moment after its birth. The collision left a bruise, a slightly lower density region, a slightly colder patch in the CMB, a mark that has been traveling toward our telescopes at the speed of light for 13.8 billion years. The cold spot. Now, this is where honesty matters. As of today, Planck's polarization data, the deepest fingerprint test we have, does not show an anomaly in the cold spot's polarization signal. In physics, a genuine primordial bruise should leave a mark in both temperature and polarization. We see the temperature signature. The polarization remains quiet. This does not kill the multiverse theory. It complicates it. And science, when it's honest, lives in complications. Here is where we are. The cold spot is real. Confirmed. The Eridanus Supervoid is real. Confirmed. They line up. Precisely. The supervoid explains some of the cold. But not all of it. We do not know if we live in a multiverse. We don't know if our universe was ever touched by another. We don't know if the cold spot is a scar. What we do know is this. Somewhere, right now, photons that have been traveling for 13.8 billion years are still arriving at our telescopes from that direction. Cool. Carrying information we haven't fully decoded. And that raises a question we can't quite shake. If our universe is a bubble, born, expanding, alone, then what is outside? And does it already know we're here?